Okay, in this video we're going to be reviewing radicals and then a little bit of geometry. So we got the square root of 48, and that needs to be simplified. So we know that the square root of 48 is not a perfect square, so therefore if it's not equal to a whole number, it's got to be equal to an irrational number, since there's nothing times itself that's 48. Okay, see, the square root of 48, that's an irrational number. That number goes on forever. So we label it irrational, IRR, put in the division sign, then we write square root times square root. Actually, you should make sure it divides by something other than 1 first. But it does, I'm just going to say. So divide by 36, a decimal. 25 is a decimal. And then 16 is 3. So I rewrite the square root of 48 as a square root of 16 times the square root of 3. So the square root of 16 then is replaced with 4. So the square root of 48 is equal to 4 whole times the square root of 3. Okay, number 2, we have the square root of 32 times x to the 7th times y to the 6th. And that's all inside of the square root. So what we're going to do here to figure out what our new square root, what our simplified expression is going to be, with multiplication we can put each factor in its own square root. So the square root of 32, and then the square root of x 7th, and the square root of y to the 6th. Now the square root of 32 is irrational. Okay? So you put in the division sign. You know it's irrational because 32 is not a perfect square. So 32 divided by 25 decimal. 16, okay? So the square root of 16 times 16 and 2. So the square root of 16 equals 4. So the square root of 32 equals 4 times the square root of 2. So I place 4 outside, 2 inside. Okay? Now the square root of x to the 7th power. Now remember, we don't know the value of x. Okay? I know that there's 7 factors of x, so then I would split that into x times x times x times x times x times x times x. It's like you're factorizing the x to the 7th. Then put that square root so it covers 2 at a time, but then this last one gets its own square root. So the reason we do that is x times x is x second, but then the square root and the second power cancel one another out, and that gives me x. X second cancel gives you an x. The square root of x second is x. So at the end we take the x times the x times the x. Well, that's x to the 3rd, and then we put the square root of x beside it. Okay? So I'm going to have a x to the 3rd outside and x inside. Now y to the 6th, that's y times y times y times y times y times y. So 2 at a time. This is how you simplify radicals with variables. So y second cancel, giving me y. Y second, the square root second cancel, giving me y. Cancel, giving me y. So y times y times y is y to the 3rd, and there's no square root. So this y to the 3rd is outside. You don't have a square root over y. So y3, no y inside. Remember, that's out when you don't end up with a square root. Okay, number 3, we have 3 times x to the square root, of 3 times x to the 3rd power, and then after the square root times the square root of 21x. Okay. 21 times x, I should say. So this is all multiplication, but there's 2 separate square roots. So that's a 3-step process. Okay, to simplify more than one radical with multiplication. Okay, so step 1, I'll write them out. You multiply the outside coefficients, that's if there are any, outside coefficients. But there aren't any, but at the same time you multiply the expressions within the square root together. So I make a square root. There are no outside coefficients in this. So 3 times 21 is going to be 63, and then x to the 3rd times x is times, and then x to the 4th. So yeah, you can put that under 1 square root. Now, step 2, you simplify your new square root, okay? And that's exactly what you're doing here. You're going to put the square root of 63 and then put the square root of x to the 4th. So again, the square root of 63 is irrational, okay? So we put in the dividing sign. And what perfect square can go into 63? Well, not 49, not 36, not 25, not 16, it's 9, okay? So, whoops, sorry, my bad. Square root times the square root of 9 times the square root of 7. And the square root of 9, of course, turns into 3. So in our new square root, we're going to have a whole factor of 3 outside, then a square root over 7. Now the variables, same thing, x times x times x times x, and then 2 of them at a time, okay? So that's x second, and that's x second, the square root, and x. So that's 2 whole factors of x. X times x is x second. There's no x remainder, so it's x second outside. So x second. Okay, then 3, you simplify the outside coefficient. You can just write simplify outside, but we really can't do that because 3 times x to the second, well, we don't have the value for x, so we can't really multiply, so it stays 3x to the second square root of 7. Okay. Number 4, 8 times the square root of 2 plus 3 times the square root of 50. Now we have an addition sign, so when we have addition we have to look for like terms. See, these are not like terms because you got an 8 and a 3 as the whole factor, whole numbers. But the 8's multiplied by the square root of 2, the 3's multiplied by the square root of 50. So as we currently speak, they're not like terms. We can't add those together. Okay. It'd be like trying to add an 8 times x to a 3 times y. Ain't gonna work. They're not like terms. So I make a table and I see if I can simplify these so that I do have like terms. Okay, so the square root of 2 is irrational, so you can carry down the 8. But the only thing that's going to go in perfect square that goes into 2 is 1, which is pointless to do because 2 divided by 1 is just 2. So that will stay 8 times the square root of 2. And then the square root of 50, okay, square root of 50 is irrational. So we carry down the 3. Now 50, I think, is going to divide by a perfect square that isn't 1, 49 decimal. 36 doesn't go into 50, does 25, absolutely. So I rewrite that as a square root of 25 times the square root of 2. And then the square root of 25 turns into 5. So the square root of 50 is replaced with 5 times the square root of 2. And then we get 15 times the square root of 2. Okay, now they're like terms. Both the 8 and the 15 are multiplied by the square root of 2. So I write the common multiplier down, and I add the 8 and the 15, and that adds to 23. Okay, 23 times the square root of 2. Okay, now the next ones can be tough, okay, to remember what to do. If you're dividing, you cannot divide by a square root, okay? So, under the division in a denominator, if you have a square root there and the square root's irrational, okay, don't simplify it, just get rid of it. Make it a whole number instead of a square root number. Okay, now I have a question for you. Then, of course, you multiply. Does the square root of 3 have anything added to it, or is it on here, or is it just the square root of 3? It's just the square root of 3, isn't it? So we just multiply by the square root of 3. And of course, this fraction I'm bringing in to multiply by, the numerator and denominator must be the same because it's equivalent to 1 whole, okay? Okay, this is where my answer is going to be. So no parentheses, okay? You want to put 1s in front of all your square roots, feel free to do so. I'm going to make a section for the top and the bottom. So the top is just 8 to the 1. But it's 8 times 1 times the square root of 3. I'll figure that out. Now the bottom, it'd just be 1 to 1, 1 times the square root of 3 times 1 times the square root of 3. Okay. So that's going to be 8, and then the square root of 3, and then that's going to be 1, and then the square root of 3 times the square root of 3 is the square root of 9. Now take those and simplify them. I would usually set this up on the top, and then this for my bottom. Square root of 3 is irrational. So drop your 8. But 3 is only going to be divisible by 1, so that will stay 8 times the square root of 3, and that's what we will have on top. Now on bottom, the square root of 9 is not even irrational, which is the point. That's why you multiply the square root of 3 by the square root of 3. The square root of 3, that's going to be 9, but the square root of 9 equals 3. Okay? Then 1 times 3 is 3. So it's a whole 3. Now you can try dividing the 8 by the 3. If you get a decimal, just leave it as a fraction. The 8, the whole numbers, divide them. And if you get something like that, don't second PRB it. Okay? If you get that, just leave it in fraction form. Okay, number 6, same thing. Get rid of square root. Okay? Make that plus negative. Now, when you see here, we didn't have anything added to the square root. When we have something added to the square root, you put a parenthesis around it, and you use what's known as the conjugate. Okay? So the conjugate of the square root of 2 plus negative 5 is the square root of 2 plus, but then instead of a negative 5, we're going to have a positive 5. Okay? Because when we do the FOIL, okay, which we'll have to do because these can't be added, that's a square root, that's a whole, that's a square root, that's a whole, the middle two will end up canceling out. That always happens when you multiply an expression by its conjugate. Then, of course, we need that same expression going on the top. Okay. Alright, so I'll split this. So this is a 6. You can put a 1 there. And you got a plus. If you have a plus, you probably want to circle that because that means there's 2 terms. You have to distribute the 6 to the 1 times the square root of 2 and a 6 to the 5. So 1 times the square root of 2 and then 5. So 6 times 1 is 6 times the square root of 2, and 6 times 5 is 30. Okay. Now, in the other part, if you want to put 1s in front of the square root of 2, go for it. So you got 2 pluses. So this is 2 separate terms. This is 2 separate terms. That is the FOIL method. So here's just distributing an outside. This is FOIL. So I take 1 times the square root of 2 times 1 times the square root of 2. Then 1 times the square root of 2 times 5. Then, that's done, but now I take my negative 5 times 1 times the square root of 2. Then I take my negative 5 times 5. So that's 1, and then the square root of 4, because you got to multiply your square roots. 1 times 5 is 5, and you just have the square root of 2. Negative 5 times 1 is negative 5 times the square root of 2. And then negative 25. Now let's bring these products over here. On the top, you got 6 times the square root of 2, and you got the 30. Now on the bottom, you got 1 times the square root of 4, 5 times the square root of 2, negative 5 times the square root of 2, and negative 25. Okay, so the square root of 2 is irrational, so we put in the division sign. But the only thing that's going to go into 2 is 1, so that's in simplest form. And then the whole number is always in simplest form. Now, so we have a 6 and a 30, but this is multiplied by the square root of 2. This is not, so those stay separate. Okay? So on bot, you put your plus sign, you just keep them separate. They cannot be added, so you just write them separately. Okay, the denominator square root of 4 is not irrational, Holmes. It's 2, so 1 times 2 is 2 whole. Remember, these are, since those on the bottom were conjugates, then the middle two always cancel on a conjugate FOIL multiplication. Then right there, that's a whole number. Well, we want to add these because neither of them are multiplied. They're both integers. So 2 plus negative 25 is negative 23. I was about to say they're both whole, but negatives aren't whole, they're integers. Now, I mean, now if you're like, how would I divide that? Well, you ignore the square root of 2. If you divide 6 by negative 23, that's a decimal. I have no desire to put that. And then you can divide the 30 by negative 23, and that's a decimal too. So I would suggest you just keep it in this formation right there. Okay. Okay, now we're solving equations. The square root of 2x plus 3 equals 7. Now, you got to find what x equals. First, though, if any variables inside of a square root, you have to solve for your square root. Then you need to solve for the variable, which in this instance is x. Okay, so here's the square root. There's no number outside of it. Okay, so I don't have to get rid of anything outside. I just have a square root I have to eliminate, and I eliminate that with a second power. The opposite of a square root is a second power. So we put that in parentheses. Square root, second power, eliminate one another, and on this side of the equation I have the expression 2x plus 3. Now on the other side, 7 to the second power. Now 7's a number you can evaluate. It's not a variable, so we'll just take, don't duplicate it. You should know how to find 7 to the second. It's 7 times 7, that's 49. Okay, now we're going to solve for our variable. So I have, in this equation, I have x only. X to the first power is only. There's no x second. It's x only. So we apply linear properties. So there's one answer, linear properties. You mark your operations, times and plus, and you get rid of the operations, getting rid of the plus or minus first. So I subtract 3, that's 46. Then we divide by 2. 46 divided by 2 is 23. Now, if you really want to, you don't have to do this. The original problem is 2x plus 3 equals 7. You can plug your solution in for x. 2 times 23 plus 3 equals 7. So this can be 46. 46 plus 3 is 49, so it's the square root of 49 equals 7. Well, then the square root of 49 is not irrational, it's 7, and I end up with 7 and 7, which checks it out, okay? We end up with the same number. Okay, number 8, negative 5 times the square root of x plus 1, and then after the square root ends, we have a plus 12 equals a 2. So it's the same thing I'm doing here, but this time when I solve for my square root, I got to do some things before I do the second power. Solve for variable, which in this case is x. So square root's on this side of the equals. Now there's some numbers outside you have to do. The second power is the last thing you do on step 1. Okay. Now you got a times negative 5 and a plus 12. You have to get rid of the adding or subtracting first. So you're going to get rid of the plus 12 first with minus 12. And then you get rid of the times with dividing by negative 5. So we minus 12, we do them in that order. 2 minus 12 is negative 10. Now if you're, then divide by your negative 5 on both sides. And that's 2. Then we have the square root of x plus 1. Now we use the second power. We get rid of the second power, gets rid of our square root. And we now have x plus 1. Then 2 to the second, you can evaluate that very easily. It's 4. Okay, now you're solve for x. Okay, you have x only. You're using linear properties, same as up here. And x equals 3. Again, if you have the overwhelming desire, you can write the original equation. And substitute that solution in for x. So 3 plus 1 plus 12 equals 2. So in the square root, 3 plus 1 is 4. And then the square root of 4 we know is equal to 2. So now we have negative 5 times 2 plus 12 equals 2. Now times comes first, so it would be negative 10. Negative 10 plus 12 equals 2. And then if I add those, I get 2. 2 and 2. So check it. You don't have to do that, it's just verification. Okay, number 9, the square root of 5x minus 1, then after the square root, plus 6 equals 10. Okay, so solve for the square root, solve for the variable, which is x. So square root, you always do the second power last. Now before you do the second power, you have to check and see if there's anything outside the square root. There is. There's a plus 6. That's it. We have to get rid of a plus 6 with a minus 6. Okay. So minus 6. And you don't have to, after you minus the 6, you're not going to have to divide because there's not the multiplier in the front. So that's 4. Second power will eliminate the square root. So we have 5 times x minus 1. And then 4 to the second's easy to evaluate. It's 4 times 4, 16. Okay, now solve for your variable. Okay. So x only, that's going to be the linear properties. One answer. So we got times 5 and minus 1. So we add the 1 and then divide by the 5. That's 17. Okay, 17 divided by 5 is going to be a decimal, 3.4. Now if you get something like that and you're wondering, well, I don't know if that's right or not, well, write the original. And we're going to substitute the 3.4 in for x. So it's 5 times 3.4 minus 1, all under the square root, plus 6 equals 10. So I'll take 5 times 3.4 and I get 17. Then 17 minus 1, 16. So it's the square root of 16 plus 6 equals 10. The square root of 16 is 4. Okay. 4 plus 6 equals 10. 10 equals 10. Okay. Alright, number 10, we have x minus 8 equals the square root of 18x. This one's going to take a little bit more time. We're doing the same thing. Solve for the square root and solve for the variable, which is x. Doesn't matter what the letter is. A B would work, A would work the same way as an x. If you had to solve for W, you'd do it the same way as x. Okay. So, square root, remember we do second power last, and the square root's over here. There's nothing outside of that, so second power is all you have to do for that first part, okay? That gets rid of the square root. Now the side that had the square root, you have the cancellation. Now over here, you can't just evaluate that because you don't know what the x is. So what you do when you have a variable inside your quantity to the second is you eliminate that and then put a parentheses just beside it with the same thing, okay? And then you're going to do the FOIL method over here. So you can put 1's in front. So 1x times 1x. Then 1x times negative 8. Then negative 8 times 1x. And negative 8 times negative 8. So 1x second, negative 8x, negative 8x, and 64. Okay? Now right below it, probably somewhere down, just go right here and do it. So you need to simplify what you just got on the FOIL. So you got 1, add the x's, negative 8 plus negative 8 is negative 16, and then you have 64. These don't cancel. These are not conjugates, okay? They're exactly the same. A conjugate's when you have a negative here and a positive here. So we write 1x to the second plus negative 16x plus 64. Now, time to solve for our variable. Well, we don't have x only, obviously. We have x second and x, okay? So that's going to be a factoring properties problem. We have x, the variable is to different degrees, the second power and the first power. So there's two answers. So first thing you need to do is clear one side. You clear the side without the x second. So you're going to clear 18x, and you would subtract that from your negative 16x. So you got your x second, then your x, then your constant. So you have 1. Negative 16 minus 18 is negative 34, and then 64. You can't do the GCFT from here because that only does you good because you need to do your F1, F2 equals 0. Well, we need to get 0 over there first before we do anything else, okay? Then GCFT. Okay, 1 is the GCF, so that won't work. 1 times 64 is 64 positive, so the signs have to match, and they have to add to the middle, which is negative 34. 1 and 64, nope. Put negative, negative. Divide by 2, you get 32, and that's negative 34. You found it. Okay, so I put my negative 2, my negative 32. So the A is 1x to the second power. So x times x, okay? And then you just have a 1 in front of it. And having a 1 and a 2, those would just divide by 1, okay? And same with here. Once you take the 1's off, you don't need them. Any other multiplier you would. So you got x minus 2 times x minus 32 equals 0. So F1, F2. So plus 2, I get 2. Plus 32, plus 32, you get 32. 2 and 32. Okay, find the distance between the 2 points. You put D equals, you're finding the distance. Remember, that's how far it is from one to another. It's something units, okay? It's not a coordinate point. That's for down here. Distance is the square root. Remember, we only learned this, you're finding the C in the Pythagorean theorem. It's like you're finding a hypotenuse, okay? So like the A squared is the x minus x to the second, plus the B squared is like your y minus y to the second. And you're like, well, why is the square root? Well, if I need to solve for C, C's to the second, I'll need to put a square root over it. So that's a formula, and that's how it's derived. Okay, so xy, xy. Substitute the values in where they go. Okay, so x and x. Well, 4 and 3. So I would start with this coordinate here. I'll put the 4 in and the 1. Then the 3 and the negative 3. Okay, so 4 minus 3 is 1. 1 minus negative 3 is 4 because it's the same as 1 plus 3. So it's 1 to the second plus 4 to the second. Then 1 to the second. It's not 2. 1 times 1 is 1. 4 to the second, 16. Then that's a square root of 17. Now, I don't want irrational decimals, okay? You mark it irrational, which 17 obviously is. And you see if anything's divisible by 17. So is 17 divisible by 16? No. By 9? No. By 4? No. So that takes me to 1, which means I'll just leave it as the square root of 17. Okay? So put square root of 17 units. That's the distance. It's approximately that, but we want the exact. Find the midpoint of the line segments with the given endpoint. Now this is midpoint. M. That's a coordinate point. Just put midpoint. So to find the midpoint, you're finding what's in the middle of of this xy coordinate and this xy coordinate? Well, you're going to add your x's and divide the sum by 2, and add the y's and divide the sum by 2. Okay? Which is not hard to do. So the x is 6 plus 8, and then the y is negative 2 plus negative 6. So this is 14, and this is negative 8. So that's 7, and that's going to be negative 4. Okay, last problem. You got to find what A equals in this right triangle. Well, that's the Pythagorean theorem. This is hypotenuse C, so it's A squared plus B squared equals C squared. So A is what I don't know, so I keep that as a variable. Then B is 4, and then C is 5. So what's 4 to the second? 4 times 4 is 16. The A stays to the second. And then what's 5 to the second? Well, 5 times 5 is 25. Now solve for the A. Well, it's A to the second only, so you're going to apply the linear properties. You have to move out the 16, which is 9. And you find the square root of the number 9. Okay, that's not irrational. It flat out equals 3. Okay, so A equals 3. 3, 4, and 5. Remember, C should be the longest. You have one. If A or B is longer than C, you did something incorrect.